If you want to go somewhere, the airlines tell you what airport they take off from, what airport they land at, and when they want to fly, and you have to meet your schedule to that.
Is it sustainable environmentally?
The European Union predicted in 2015 that global CO2 emissions coming from aviation go from about 2% to, by 2050, being something closer to 20%.
We cannot be in a position that this industry, the aviation industry, takes such a large chunk of the total carbon footprint and energy use footprint.
Steve Wright spent over 25 years working on some of the largest aeronautical projects in the history of aviation. Now helping to teach the next generation of aerospace engineers, he understands better than most the challenges faced by those seeking to move away from fossil fuels.
Hydrocarbon fuel has been God's gift to the aviation engineer like me for the last 150 years. And let's explain that. Let's put a number on it. Fuel as we know it, it contains about 40 megajoules per kilogram. Good old nature has stuff called lard, food of champions, 37 megajoules per kilo. Dynamite, for example, only 6 megajoules per kilogram. It's just very good at letting out that energy very, very quickly. But now let's talk about our batteries. A battery, current state of the art, probably only about 1.5 megajoules per kilogram. Admittedly, electric engines are probably about twice as efficient as the internal combustion engine, but it's still only a fraction of what we can achieve with petrol.
When Norway announced that within just 20 years, all of its short-haul flights must be on electric aircraft, it sent shockwaves around the aviation world. But a new breed of homegrown aviators have already risen to the challenge, intent on creating a green revolution that only a handful of years ago most would have deemed unthinkable.
Well, this story really starts in the garage, you know, moving back to my parents' place, starting to build and design parts for the airplane.
Thomas Brødreshift isn't your typical aircraft designer. He actually intended to have a career working in industrial product design, but a decision he made when looking for a case study as part of his degree would change his life.
I came to thinking that wouldn't it be interesting to use some of the industrial design processes to see if we could create aircraft that are different. So I basically used the exact process that you would normally see if you're doing a bicycle or a coffee mug or whatever, because the process of designing something is more or less the same. You have to analyze the way that people use the products, the way that they interact with the product.
And what he realized was that people were quite dramatically changing the way they wanted to travel.
Living in Norway, we're already up to 30–40% electric cars. So for me, the first time I drove an electric car, I felt like this is definitely the future, right? It's silent, it's clean. Once you go back to the combustion engine, after that, you're shifting gears and you're listening to the explosions inside the engine, and you kind of feel the heat and everything, and you think, wow, this is not the way to go.
Norway's rugged terrain has always presented challenges to the traveler. But Thomas became gripped by the idea that electric aviation just might be able to turn one aspect of this dramatic landscape to his advantage: water. And in particular, Norway's 450,000 lakes and fjords.
The main challenge, which I find fascinating, is trying to make a flying boat that can fly as efficiently as a land plane. And the whole reason why this is possible is the electric technology. The whole reason why we can suddenly do this is because we don't have to bring a big, heavy combustion engine with the propeller. We can start to distribute the power with a light electric motor, and suddenly there are so many opportunities that the last designers the last 100 years have not had. You can suddenly make aircraft that are completely different.
Since those early years, Thomas has been joined by a small group of highly talented, like-minded individuals. And today we'll see the culmination of over a decade's hard work, dedication, and belief as the team prepare for the very first test flight of what they hope will form the blueprint for a new generation of seaplanes. But before they can even think about taking to the water, they need to establish whether the plane can fly at all.
2 or 3 people designing a plane here, so none of which have done it before, ever. Everything in this plane's been made by hand, by us. And of course we've done everything we can to verify every single detail. But at some point, somebody has to take that plane off the ground. And you want the person that can handle the worst case scenarios, who can keep their cool, and you need a professional. Otherwise we might end up crashing the plane if something is off. And the chances that something small is off is quite high with a concept like this.
And the person chosen to take the controls is Eskil Amdahl, Norway's most experienced test pilot. A man who has flown everything from World War II fighters to the latest F-35 Lightning.
Because everything is theoretical up to the point where this aircraft leaves the ground. Everything is just on paper. So you have an aerodynamicist saying, yeah, it's going to be stable, but you don't know until you fly it, right? So it's this extremely nervous time, and I really, it's almost a blur for me, everything up to the test flight.
Okay. Head. Good luck.
Härligt!
Fantastisk ribba.
Seaplanes aren't new. People have been doing them since the dawn of aviation, of course. But we're traveling from Oslo to Hamburg, for instance, and we want to land on the river next to the city. This is not allowed today because of the noise that the combustion engine and the high rev propeller that these seaplanes need to get out of the water produces. It's something that people have been pushing away from cities, basically. So with the electric technology, of course, this can completely be reduced by a huge amount of decibels, maybe 50% lower, and you're down to like a normal boat or something. At that point, you can't really argue that these airplanes shouldn't come close to the cities anymore. So that's the big change, you could say, that will come with this, is silent green products should be able to come closer to the cities. It's really strange, but it's first kind of relief, but it's almost like a dream, and it became very emotional as well, and especially when Eskil also, I remember he stepped out of the aircraft and I gave him a big hug and started crying. I never cry, but I cried. In 10 minutes you get the answers for 7-8 years of work, right? The test pilot has this amazing sensoric equipment, right? The body, and he can immediately feel everything that works, everything that's wrong. I think in any prototype where there's a novel plane, where there's a geometry that's never been tested before, it's extremely hard to hit the mark without getting a list in the end of things you have to change.
Thomas and his team at Equator are now building up to sea trials, while at the same time using the test data to develop a new 4-seater version. With a flying time of 2 hours and a 500-kilometer range, which he hopes will go into production within just 2 years. But that's only half the story.
So the big question is, who's going to take responsibility for investing in and changing the airport infrastructure and the harbour infrastructure to be available so that people can charge their electric planes? We are there with a product ready. We need it to happen in parallel. Otherwise, it's completely unsustainable in a way, the whole project.
One of the things that we need is universal systems that we can all just walk up to and plug into. What are we talking about? We're talking about what kind of voltage we use, what sort of power we can deliver and how long it'll take. And in the simplest case, it's what shape is the connector that plugs into my aeroplane today.
Aware of just such issues, Sweden and Norway have jointly set up Green Flyway, a unique international test arena for future aviation. Covering a vast area and including 2 international airports, it's a place where designers, engineers, and aerospace companies can develop ideas, test theories, push boundaries. The scheme represents a bold statement of intent and is attracting aviation pioneers from around the world.
I'm representing Pure Flight from, it's a company from Czech, and we have developed this airplane. It's an all-electric airplane with a 35 kilowatt-hour battery and can fly around 3 hours plus with a lot of reserve.
Winter conditions are just one of the many challenges electric aviation must be able to cope with to satisfy not only regulators, but also future operators. Green Flyway is also enabling airports to understand what infrastructure they will need and how best to supply it. But if electric aviation is to make an impact in the mass market, there will need to be a larger solution. Inspired by Norway's bold directives, Anders Forland and his partner Clara Andresen believe they have the answer.
This is the heart, ES-19. It's a 19-seater all-electric aircraft with a range of 400 kilometers. And our goal is that this aircraft will be certified for commercial service by 2026.
It's a huge moment for this new startup, in front of some of the most influential people in the business, not to mention members of the Swedish royal family. They are about to share their vision with the world.
And I realized this is not a research project. This is something that we need to commercialize now.
They may not yet have a plane, but they do now have a way of powering it. Or, to be more precise, they almost do.
Yeah, we had a little bit of a hiccup, I guess, when we were doing this thing. We think we've isolated the problem, and it really goes to show that you need to iterate on the design. So now it should be fixed, and we should be able to run it.
If this company is to capitalize on the interest they have generated, it's imperative that a series of vital engine tests are successful. But in an industry not known for doing anything quickly, what they have achieved so far is nothing short of remarkable.
Our journey started in early 2018. At that time, I was a researcher at the university here in Gothenburg, and I just come back from a researcher exchange at MIT, and I was really convinced that electrification is the future. And if we wanted to do this, we had to start creating a company now, because the technology is already here.
Anders' passion was shared by his fiancée Clara, and together they applied for seed funding from Y Combinator, an American investment program that has helped launch many companies that have gone on to become household names.
I quit my job. Clara quit her job.
It was mixed feelings in the beginning because I had a really good job and like a secure income and everything. And but like we understood, both of us, that this was going to take so much time and energy. So either we do this together, or, I mean, we can't really be together.
You know, at this point where you're like two people and you say you want to build an aerospace company, it's like you're taking on a huge challenge, and you have to be, I guess, a little bit crazy, but it's, I guess, if you're crazy enough to think you can do it, then you're halfway there.
By the summer of 2020, they'd secured hangar space, offices, a small dedicated team of 12, and a concept that was beginning to migrate from the drawing board into something more physical.
Let me show you around a little bit. You need to take a cue from the startups of the software industry, where you have a small team that's talented, that has engineers that are working a little bit harder, that are using all the latest tools. And if you just get that sort of mixture right, you can take on the world. And here's Nigel. Hey, Nigel.
Hello.
Yeah. His resume is almost like a modern history of aviation.
Nigel Pippard's official title is Chief Technical Officer. But amongst a team for some of whom the ES-19 will be their first aircraft, he's affectionately known as Gandalf.
We found some of the best people in aerospace that I'm amazed every day to be able to come to work with these people. To discuss as well, should we take a step back, go back to the drawing board, or is there a virtue in just pushing ahead and seeing where this iteration takes us? Then we have Benjamin, and Benjamin he's something out of this world. He basically created, so there's this thing called electronic motor control, and it's how you program the electronics so that you can make motors spin. And he basically created a global standard for this out of his basement. His software has made its way to, I think around 200,000 different electric machines, everything from, electric skateboards and motorcycles, and even he's working on one project to build an electric heart, which is really, it's funny because of the name of our company.
The thing I love about this whole electric revolution, it's actually a piece of physics that's been around for 150 years. Visualize a series of electromagnets in a ring and a bar inside it. So we switch each electromagnet on in turn, and causing a big piece of metal to jump between different positions. We want to switch those magnets in and out really, really quickly, but we need to switch them in smoothly. We need a gentle handover between them. Otherwise, the thing will lurch around and it'll buzz and it'll shake and rattle. So what's changed that's made this all possible? The extra magic that made it all possible was cheap computers in the 1980s. The moving parts in this thing is simply a lump of iron in the middle. But what does it give us? It gives us an incredible force, something that a conventional electric motor can't.
And the fact that we as a small startup can develop something with the performance of the jet engine and efficiency that's about 3 times better, and do that in 5 months, I mean, it's too good to be true for an engineer. It's really, really exciting.
So this is the equivalent for the 21st century of the mechanical engineer in the garage tuning his internal combustion engine to get that perfect sweet note and the best performance out of his engine. But these guys today, they're using software.
The entire electronics and software for the entire rig here is something that we have, that I have written mostly by myself. I think for the certification, to make sure that everything is safe, you almost need to be able to build a system like this in order to understand it well enough.
And that certification process is also behind what to some might seem the rather unusual choice of having 19 passenger seats. In reality, it's just one of many examples of the pragmatic approach this young company is taking to get a large electric passenger plane into the skies as safely and quickly as possible.
This year, the first electric aircraft was certified. So that was the Pipistrel Velis Electro, is what it's called right now. It's a 2-seater aircraft. And that's a certification basis
Certification signifies the airworthiness of a particular category of aircraft and is needed for serial production and commercial operation.
That extends up to 19 passengers. So we can use that framework that they've used to certify that aircraft to certify ours. And that's why we can have a very aggressive timeline on when we want this aircraft to be in the air. If we go to 20 seats and above, it becomes the same certification basis as a jumbo jet, essentially.
So what they're doing here is sensible. It's an incremental step. They've seen an opportunity that they don't need to completely reinvent the aircraft. They only need to address the propulsion system.
But if this vision for a brave new world is to become a reality, Anders and his team need to prove that their motors and batteries are up to the task. As a simple way of recreating how a motor would drain the batteries in real life, they've come up with the ingenious idea of using an array of halogen light bulbs.
And the thing that happens is that when you're just starting, we draw the most power because you have to take off and climb. And then eventually we get to cruise when we don't climb anymore, and then the power is going to drop. You can probably hopefully see that the lights get dimmer now, and that is because we need less power to just keep the same altitude and keep going. As far as we can tell, these batteries are going to last for a very long time, and that makes me really positive to this whole thing.
Theory is one thing, but will Benjamin's latest software work in practice?
We connected the battery module to the motor controller now, which can provide probably 10 times more power than we could before. Now we have the full voltage of all of those modules in series through the fuse to the power switch. And now we'll go and switch it on. Don't broadcast it if this thing catches fire now. Spinning it up at much lower power, but with the full voltage, and see how that goes. Seems to run fine so far. So I'm gonna push it a bit more. I'm gonna increase the limits a bit.
It's difficult to overstate how important this test is. The motor represents the very core of the entire project.
That didn't sound so good. If the fuse does blow, then we're probably going to have a problem, because then we get a huge inductive spike. But yeah, let's go for a risk.
Don't do something stupid. Yeah,
yeah, I'm getting too confident here. Yeah. But let's set it to 70 amps, then we're probably safe for the fuse at least. Okay, so should we go? Yeah, that's a bit more wind.
The ES-19 is now one step closer to reality.
We have to increase that 10 times again.
Yeah, but that's the next step.
It's not the act of time passing that makes a new technology grow. It's the work of engineers that are working, and pushing the technology towards their edge. One of the most rewarding things of what we're doing is that you find out that there's an extra gear. There's one, you might think that you were doing your best or working as hard as you can, but there is actually an extra gear that you can find where you can turbocharge what you're doing and achieve much more than you think that you ever could.
But what if you don't want to wait a few years for a new electric aircraft? When de Havilland's DHC-2 Beaver first flew in the summer of 1947, few could have imagined that over 70 years later, the same airframe would herald a new dawn in the history of aviation.
To take that aircraft that you love, that fits your needs, that does what you need it to do except for that engine, convert it to electric, can actually make sense. And so we're enabling the operators, no matter what their path is and their growth is, to go electric.
Which is exactly what Harbour Air in Vancouver chose to do with this iconic float plane. But it required more than just a straightforward swap.
When you go from a large, heavy radial engine, for example, on the eBeaver, and you go to a small, lightweight electric motor, in order to maintain the center of gravity of the aircraft, we had to put the motor more up front. So we basically elongated the nose of the Beaver, making it more aerodynamic.
In December 2019, its 750 horsepower electric motor was about to be put to the test. With the attention of the world's press fixed upon it, it would attempt to become the first full electric commercial aircraft in history.
Even without the electric aspect of it, the aircraft became more aerodynamically efficient. So we could, with less power, fly the same aircraft, which was a tremendous lesson in itself.
Following on from their success with the 5-seater de Havilland, Magni X turned their attention to the much larger 9-seater Cessna Caravan, a rugged workhorse used the world over.
When you're doing something that wasn't intended to be done, then there will be both losses and gains. If we take the Cessna Caravan, for example, on a regular engine or with its internal combustion engine, you'll be able to fly up to 1,000 miles in range, 1,000 miles, which is phenomenal. Now, no one really flies 1,000 miles in a Caravan. There's no restroom, it's unpressurized, etc. But it can fly up to 1,000 miles. On batteries, the electric version can only fly about 100 to 150 miles with today's batteries. The flip side is your costs have gone down significantly. For an hour-and-a-half flight, you'll spend $24 on electricity, $24. Compare that to the same internal combustion engine Caravan. For the same 1.5 hours, you'll spend $404 on fuel. $404 compared to $24, that's fuel alone.
The potential niche appeal of such retrofits is just part of the picture. In reality, they are serving a much larger purpose.
So if you were to go a year ago or 2 years ago to a battery company and say, hey, why don't you guys develop a power source, a source of electricity for an electric plane? The answer would have been, what electric plane? Had you then gone to airplane manufacturers and said, hey, why don't you guys develop an electric aircraft? The answer would have been, with what propulsion system? Now there's a propulsion system that is powerful enough, lightweight enough, reliable enough, redundant enough, etc., to power an aircraft. Now design these aircraft for it.
Which is exactly what a physicist based in Israel decided to do. But first, he needed a company to make it. So he started his own.
A lot of people, when we started this endeavor, a lot of people asked us, well, you intend to be the Tesla of the skies? And we said, no, this is the wrong comparison. We're trying to build the Model T of aviation. We're trying to build that aircraft that allows regular people with regular income to use the skies for regular transport. That's very different. That's not your odd vacation business trip or, flight to visit auntie someone. This is your day-to-day commute, reinvented.
Having a dream was one thing, but the big question was, would anyone else want to share it?
So you need your operators to really be in a position that it makes economic sense for them before you can say, okay, don't worry about it. I'm going to build a car-like aircraft and everybody's going to buy it and it's going to be fine. The it's going to be fine part is not really part of the aviation industry on a day-to-day basis.
The sector they wanted to target were the operators of small regional aircraft. After much consultation, it turned out that 9 was the magic number. But in order to break into the market, they were going to have to come up with something pretty special.
So the Aviation Alice is a 9-seater aircraft, 9+2, meaning it has room for 2 pilots or crew members.
With a range of over 440 nautical miles and a cruising speed of 220 knots, the Aviation Alice offered the promise of low operating costs made possible by its electric motors. It was enough to secure a substantial prospective order, which meant that the pressure was now well and truly on.
One of the things we did, actually the first investment of this company, was to buy a really obscenely large supercomputer and use it for simulation. I think at the end you can simulate as much as you want. At the end you need to actually build it and see how it works. So how many planes we've built before Aviation, Alice? The simple answer is 0. As a company and as a person, we've never built a plane. And I think it's, I don't want to call it refreshing, because it's obviously there are some advantages to coming in to a project with the enthusiasm and the kind of clean slate design and thinking. But in all honesty, this is a very, very humbling industry, and there's plenty to learn.
Omer and his team reached out to over 100 experienced subcontractors in more than 20 countries.
We had to go through the, jump through the hoops and convince them that this is worth their effort and this is worth their risk sharing so that they can be on board this aircraft. Some of them are huge names that everybody knows in the industry. Some of them are smaller players. But yeah, the joke in the company goes, how do you build a plane with 50 people? And the answer is, well, together. You need a lot of people working with a lot of other people and a lot of kind of expert groups. So there is a design, but it doesn't mean we're the best people to, for example, build the tooling and actually execute on building that wing.
One company that took no convincing was Magni X.
When you can design something from scratch and have higher redundancy of propulsion systems and put them in really efficient places because they're suddenly small and lightweight, you can do some amazing things. The Aviation Alice has 3 motors, 2 of them on the wingtips. There's a lot of aspects to that increase the efficiency of the aircraft. For example, sometimes you see these really cool movies of aircraft flying through the air and they have these really nice smoke swirls on the tips of the wings. It's really cool visually. It's really bad for the aircraft because this creates tremendous drag on the aircraft and it's basically pulling the aircraft back, which means you have to put more power in order to move forward. Imagine if you could put propellers on the wingtips that rotate exactly the opposite to those swirls you get to see, basically eliminating them. Suddenly the aircraft can fly smoothly through the air and have less drag, which means you need less power to fly. When you have propellers at the tips of the aircraft, you can actually use them to help you control the aircraft. So imagine today what's known as crabbing. When you're coming into land and there's a strong side wind, because the engine is either on 2 points on the wings close to the body or in the center on the nose, then what you do is you come flying into the airport almost at an angle, sometimes a very extreme angle. Again, you can see this if you look at kind of side wing landing videos. You can see the aircraft flying on a side into the runway and you think, oh my God, how is this thing going to land? And then at the very last minute, they straighten out and land. Imagine if you could independently control the 2 wingtip motors. You could, as a pilot, fly nose straight into the runway exactly as you would want to without trying to manipulate the aircraft. And so it allows you to really do things, again, that up until now have simply been physically impossible.
By 2019, they were turning heads at the Paris Air Show. But although it was potentially capable of flight, this plane was scheduled for intensive ground testing in America.
Yeah, it's an aircraft, it could fly, but what is it good for? There are a lot of planes out there that are flying their maiden flight, and that's it. It's a proof of concept. Even if they achieve something amazing, like they break a record or they fly very far, very high, that's great, but that's not what we're trying to achieve. This is a company that's building a product. This product needs to be safe, it needs to be certifiable, and it needs to be manufactured in scale for a price that makes sense for the industry. And that pushes you And in some cases, pushing hard gets you to a place that's risky.
At the start of 2020, just a few weeks after the aircraft had made a sensational debut at Paris, the Aviation Alice was hitting the headlines again. During ground testing, the aircraft was damaged by an electrical fire caused by batteries. Ironically, the fire was caused by a fault with ground-based equipment, but inevitably, it raised questions about the safety of battery-powered flight.
If you're worrying about batteries, let me give you this thought. Let me put your mind at rest by suggesting, how would you have felt if somebody had turned up with a jet engine as a brand new thing? Imagine what we'd be up against if we tried to persuade somebody to get on board a vehicle carrying 100 tons of kerosene, and then someone explains to you that they're going to set fire to it just over there on the wing next to where you're sitting. You might be alarmed by having a fire. All I'm concerned about is, can we contain that fire when it happens? Because the fire, it's a sign that we're pushing the technologies, we're discovering the boundaries of where we can go. One way I always put it is, we as engineers have suffered, so you, the customer, doesn't have to.
As one of my good friends in this industry told me, Omer, you're building an aircraft, you have all your people safe, 3 wheels on the ground, and the aircraft is still standing. That was a good day. The testing campaigns that we're taking are part of the development process that you cannot avoid. If you're avoiding it, you're not going to have a proper product at the end.
One design change that came about as a result of the fire was another layer of safety. The battery system was separated into 16 fireproof compartments, each with enough energy to safely power the aircraft on its own.
If, God forbid, it happens, and obviously you need to prevent it, it's still safe for the mission and for the passengers. Maybe you won't get where you wanted to go, but the idea of aviation is not just prevent failure. It's if something happens, fail safe. And that's where we're going, and I think right now on the battery front, that's where we are.
With flight testing about to begin and an estimated price tag of $8 million, the Aviation Alice has already secured high demand for potential orders, and the company are already planning an ambitious production run.
I think hundreds per year that will add up to quite a few thousands within a decade would be a realistic approach.
Although the electric aviation industry may be in its infancy, there's general consensus that as battery technology improves, its growth will be rapid.
Anecdotally, when we started flying the eBeaver, we had batteries that were about 145 watt-hours per kilogram. Today, we're already seeing batteries at 400 watt-hours per kilogram. This is less than 12 months later.
On the one hand, the chemists are going away and discovering new chemicals that allow us to cram more energy into the very box itself. Then there's systems engineers like me who are finding ways to operate those batteries more efficiently, to nurture them and coddle them, as it were. And in the middle, the electrical engineers can arrange these cells in different configurations as well. Do we put them front to back? Do we put them side by side? All these options are up for grabs in this brave new world.
Britain's Cranfield Airport describes itself as an ordinary licensed aerodrome which carries out unusual research. Although today this is just a ground test, this same plane, operated by Zero Avia, was the world's first commercial-grade aircraft to complete a flight powered by a hydrogen fuel cell. A hydrogen fuel cell is a device which uses hydrogen gas together with oxygen from the atmosphere and converts their chemical energy into electrical energy, which can be used to drive an electric motor. When Zero Avia made their groundbreaking flight in September 2020, it was hailed as a landmark moment.
In the conversion process, So taking the chemical energy of the hydrogen into usable electric energy on the aircraft, you combine hydrogen, H2, with oxygen from the air, which is O2, and bringing that together creates H2O, water. And that is really the only waste product that you have on a hydrogen electric system like ours. And that water you can discharge during flight, and it does not create harmful emissions or any climate effects.
Their first flight was only around 15 minutes. Now they're testing the systems in preparation for a flight that will last over 2 hours and cover 250 miles.
Now, of course, as this gets rolled out commercially, you will start needing to have stationary infrastructure. And that is something that we are working on as well, to make sure that at an airport you can produce hydrogen from renewable electricity, so zero emissions. You can store it on site, and you can fuel it into any aircraft that you will want to fuel. What you see here is on the left of the container, you see water, just regular water. And that water gets used in the electrolyzers. The electrolyzers take that water and split it with electricity. And that electricity can be green, it can be zero emissions, it can come from solar or from wind. And that's really how you produce green hydrogen. Storing the hydrogen is not enough, you need to actually make it usable. And making it usable happens with a really standard fueling system. So you have this nozzle here that you plug into the aircraft, and then you press the start button on our system. The system fuels the aircraft, and once it's full, it is ready to go and fly 200, 300 miles.
This retrofitted Piper M Class 6-seater is destined to only ever be a flying laboratory. For commercial operations to be a success, the team here at Zero Avia will have to accommodate something considerably larger.
In fact, hydrogen is actually 3 times as energy dense as jet fuel per kilogram of fuel, which is really exciting.
As an example of why it's so important, the maximum takeoff weight of an Airbus A380 is 565 tons. If its tanks are full, fuel will account for 254 of those tons, 45% of the total weight. Reduce that weight, and you reduce the energy required to fly the plane.
Because that's ultimately what really matters in an aircraft. As you move up the scale of aircraft, at some point it simply becomes infeasible to fly with batteries. And at that point, you have to switch to hydrogen. So our vision is actually developing a system that is scalable across the entire range of aircraft. You have first commercial use cases actually as early as 2023, but ultimately the system can scale from something like a 6-seat aircraft to a narrow-body aircraft like an Airbus A320, which is something we'd be looking at in the 2030s. There's always a strong sense of purpose. I think you can feel that across the entire team, that everybody's really dedicated and actually making sustainable air transport. 50% of the world's air travel is less than 500 nautical miles. That's exactly the kind of market that we are targeting with our hydrogen electric powertrain. And that is why we're so excited about its potential, because you can eradicate all carbon emissions from 50% of all flights today.
It seems like a silly little toy, but in fact, it contains all the systems that are shaping a whole new sphere of electric aviation.
At Marina Bay, Singapore, a team from the German company Volocopter are making last-minute preparations. They hope that this aircraft will be able to make a landmark flight that could shape the future of urban air mobility. The origins of this remarkable story can be traced back to 2011, when Alexander Zozel and his friend, software designer Stefan Wolf, unwittingly became internet sensations.
Well, it all began when I saw these small little multicopters, I mean the remote-controlled ones. You know, I'm kind of a technical guy, so I thought, what would it take to scale it up such that a human can fly with it?
It was the first manned flight of a vertical takeoff aircraft powered by electric motors. But it was their choice of undercarriage that also captured people's imagination.
We were thinking about a solution that was very lightweight. And it turned out that these yoga balls are approved for like 400 kilograms or so. Even today, if you ask someone, volocopter, what's that? Ah, we did this thing with the yoga ball. Ah, yes, I know the yoga ball. That's the story.
You know, up till then, it was really just a, let's prove that this is possible. But then the public reaction this triggered, both from the broader public as well as from a lot of aviation experts. They came back to us and said, guys, this is fantastic. We've been theorizing about distributed electric propulsion for decades, and here you go actually proving the point, because this opens up a whole new paradigm for safety in aviation.
Spurred on by the enormous interest, they secured funding and began seriously developing the concept.
I thought that it's so obvious, many people in this world would be working on it. Later on, it turned out for years there were no followers. I mean, we were the only ones.
Young companies are like young people. They create these wonders because they're too busy doing something else when they're being told that it's impossible.
Now, when we started out, there were so many people telling us, guys, do you know all the problems that you're facing, right? And we said, luckily we don't. You know, so now looking back, many people are like, okay, it took outsiders to take on this view, because an aviation insider would have never set out on that journey. All he would have seen were challenges and problems that seemed, you know, unsurmountable to him at that time. We try to maintain that original spirit for as long as possible, because it's made possible what was viewed as not being possible at the time.
It was not the original idea to be a pioneer, but then it turned out we are.
A team of 10 became hundreds. Satisfying the rigorous demands of certification meant that every part of the system was redesigned, made safer, more reliable, able to cope if something went wrong.
We have redundancy in all of our critical components, right? Most visible in our electric propulsion unit. So we have 18 propellers, and obviously a number of those can fail and we can still safely complete our mission. And this is completely new. If you look at a traditional helicopter, there's a whole very complex change of components, mechanical components, that if one of those elements fails, the entire aircraft is in serious problems. And that's very different here with the volocopter. And this safety architecture allows us to build air vehicles that we weren't able to build in the past, that are much, much safer than what we know today.
This, combined with the much lower noise levels, means that objections that are previously applied to helicopters operating in cities could potentially be addressed. Which is why this flight in Singapore was so important. Having secured permission to fly here, Volocopter hoped that it would be a glimpse into the future. Duncan Walker from British company Skyports was responsible for creating what can best be described as a temporary pop-up airport, known as a vertiport.
Yeah, hundreds of people in the vertiport were waiting, and it was torrential. Absolutely, you know, like Singapore, it just poured with rain, poured and poured and poured.
Not so happy about the weather. A little bit nervous that the whole event would not happen.
It's military airspace, so you only get a defined area. It's not like you can just kick it down the road and say, oh, we'll do it at 2 because 1 o'clock doesn't work. You're doing it by midday or you're not doing it. So we had all these people cutting the ribbons, press, the TV crews were there. And at the last minute, the skies opened up around the bay. It worked perfectly, but I don't think at the time they realized quite how close it was to not going.
It was a very special day for me, of course, yes. I mean, obviously.
And we got incredible feedback from regulators, from city officials, from administrators, but more so from the public who, for the first time, had been able to see it, sit in it, understand what it was, hear it, or more importantly, not hear it. They don't even turn around because they don't know it's there. So there's a load of really great things we could take from that and then apply them to other cities around the world.
We don't want this to be a rich man's toy, very similar to helicopters are today. We want this to be a professionally operated fleet available to the public. That means the citizens and the visitors of a city. And by that, we can actually democratize the access to this new technology. And we can scale our services to a degree we have the potential to offer this at the price slightly above today's taxi ride, which really makes it accessible to broad audiences around the city.
But this is just the first part of a far more ambitious plan. Initially, these aircraft will have pilots. However, in the future, the intention is for them to be autonomous. But what exactly does that mean?
Automatic, we press the button, the aircraft flies from A to B, which is fine until there's a balloon in the way. Autonomous, the machine chooses, and we hope it chooses to fly around that balloon.
From a technology perspective, we can do it, even today.
We can, for example, automatically detect emergency landing sites along the trajectory, whether it's free and good to land. We can detect birds or elements like another aircraft or even small drones at sufficient distance in order to initiate a countermeasure in order to avoid such an obstacle and avoid any conflict that might occur. So that's technology we can already showcase today, but we continue to work on those with a host of partners, such as research institutions and commercial partners as well.
There are a number of challenges for urban air mobility. I always put them into three buckets. There's regulation, there's technology, and there's social acceptance. Technology you can solve. If you throw enough money and enough brains at it, you can solve the technological challenges that are being worked through at the moment. Regulation is on the right path. Timing is less easy to influence than technology, but there's momentum there, driven by business case, driven by innovation, driven by safety cases. The big unknown is social acceptance. When this is ready to go, do people adopt it as a form of transport? Do people embrace it? Do they love it because it's saving them time, solving problems? Or is it a bit more of an unknown that people are nervous about using and takes a longer time to get up the adoption curve and really scale?
But could drones offer a means of socially acceptable transition? Duncan and his team have already begun trials with drone deliveries of medical supplies to remote Scottish islands on behalf of the NHS, the British National Health Service.
It's really exciting to be flying drones for the NHS, and as COVID hit, it really accelerated what we were doing with them because it made what was a routine delivery a really critical delivery, flying COVID testing kits between the west coast of Scotland and the Isle of Mull. Very challenging, certainly in remote areas, to put in new roads, bridges, tunnels. But drones can circumvent a lot of that. They can provide services to communities which are underserved with existing infrastructure and can really change lives very dramatically in a short space of time. The future is undoubtedly autonomous. It's actually easier to do autonomy in the sky than it is on the ground because there's fewer random events, there's less balls bouncing down the road and kids crossing the road.
In recent years, there has been a proliferation of new companies entering the urban air mobility market, hoping to be part of this new autonomous revolution.
There's nearly 200 companies out there in the world at the moment, and that's not including the ones that are working in secret, and there is such a thing.
One company, EHang, based in China, has even begun making autonomous passenger flights.
So they've been able to create a very, very nurturing environment within their own borders. The problem is when they come to export into the wider world.
The regulatory regime in China is very different to the rest of Asia, to Europe, to the US. And in controlled environments, they can do things, frankly, just much more quickly than we can do in the Western world. How that translates to the Western world is a bit of an unknown.
There's going to be an issue of how do we mesh those different regulations. And it's going to become a political issue. And only time will tell to see how that plays out. So what about the future of urban air mobility. That's going to be up to us, frankly. We've got the technology, we know what we can do. The biggest issue is going to be, do we want it?
Without question, the way we fly is about to change. A change that is not being driven by the conventional aerospace industry, but by a new breed of aviators, not afraid to think differently.
As long as we continue to say, well, if the solution isn't 100% and it can't do all of my ranges and replace all of my aircraft, I'm not going to do it. That's putting your head in the sand and saying there's no problem. Instead, change the way you think and look at it piecemeal. If there's something I can solve today, let's solve it.
You have the power to actually do something yourself. With that power comes the responsibility to do something about it.
So here we had some guys who built something in their garage and showed to the world it's possible, but all the aviation industry had nothing.
It starts on this level of small, light planes, and it will grow into larger systems as we move ahead.
Technology is the only key that I see to open up a brighter future that can be sustainable at the same time.
If we can be sustainable with all of these aspects together, we really change the way we live. And I think it's about time we did that.
I wish I was starting my time in aerospace now, because it really is the most wonderful time. It's a brand new beginning.
Gavin Allwright represents a growing number of technology developers, shipbuilders, and operators intent on reshaping the future of global shipping by harnessing a resource that has transported humankind for millennia.
So it's strange, when we look at wind farms or wind turbines, we see those now as modern renewable energy solutions. But when our mind's eye turns to wind-powered vessels, we think of that as being old-fashioned. Now, there are still traditional sailing vessels out there delivering cargo, but there's a whole new breed of naval architects, designers, who are using cutting-edge technologies to power the vessels of the future.
This is Black Pearl, the world's largest sailing yacht. Many in the shipping industry believe she could form the blueprint for a new generation of commercial sailing ships. It's been 2 years since this extraordinary vessel took to the sea, and having proved herself on the world's oceans, she's returned to Holland where she was built, for what can best be described as some fine-tuning.
It works well, but having said that, one of the reasons we're here in Amsterdam is that we're tweaking, we're improving, because we believe we can make it better.
Chris Gartner, skipper of Black Pearl, appreciates more than most the ancestry of this 21st century sailing ship.
The inspiration comes from the clipper ships, for sure. The Cutty Sark or the Stad Amsterdam, the high speed that they traveled, super efficient using the wind.
To give some idea of just how efficient these clipper ships were, we need to look no further than the Flying Cloud. In 1854, she set the world record for the fastest passage between New York and San Francisco, 89 days, 8 hours. That record stood for 130 years. It was only surpassed in 1989. And this was a vessel with no motors or engines at all. Large wind vessels were still operating right up until World War II. These ships were seriously fast. Some of the clippers could exceed 20 knots. Many modern ships don't do that.
The old sailing ships did require a large crew. On deck, they'll run with about 16 people. and they can drop all their sails or set their sails in approximately 25 minutes. Then carbon fiber came, and the game changed. Voila, we come with the Dynarig. We can maneuver the boat at sea with one person.
The Dynarig system utilizes rotating masts to achieve the optimal position for its square sails. First conceived of in the 1960s, it was not until 40 years later that there were materials strong and lightweight enough to be up to the job. Towering 232 feet above the waterline, Black Pearl's 3 enormous masts are the largest example of the system by quite some margin.
They are built to be freestanding, and they're like a big carbon fiber fishing pole. We carry 2,900 square meters of sail area, which we can deploy in just over 7 minutes, but more importantly, we can furl them away or close all the sails in just under 7 minutes.
Being able to react quickly to changing wind conditions makes for more efficient sailing and greater energy saving. And what's more, it's all done by remote control.
Basically, you have to take 3 big, deep breaths before you really start exerting your finger. No, but it's as simple as that. What does it feel like when we are sailing this boat? It's incredible.
Just over 24 knots is our max under sail so far. The prediction is with the right winds and stuff, we should reach 28, 30 knots.
Which is the equivalent of over 34 miles per hour.
Well, I think we had a classic example on our very first voyage from Rotterdam down to Gibraltar, where one of the Portuguese coastal stations called us up. Black Pearl, can you please confirm that you are a sailing vessel? Yes, we are a sailing vessel. And there was a slight pause there, and then there was this Black Pearl, are you actually sailing? Yes, we are actually sailing. And at the time, we were doing 22 knots, I think it was, and passing all the cruise ships, the container ships, and the tankers and motorboats, and they just couldn't believe it. That was a great trip.
But the designers of Black Pearl were determined to take things a stage further. When under sail, the propellers of the ship can be used as underwater turbines, generating electricity.
Let's have a look in the engine room. This is our main engine, our starboard main engine. Attached to this is the gearbox, and on over this side, our electric motor, which gives our electric propulsion when we want to drive off batteries. So we have the option of running on diesel or electric, or a combination of both, which gives us our maximum speed. So obviously when we're driving the boat, the propulsion is that way. When we're sailing and regenerating, the power comes back through the shaft into the electric motor here, and is then distributed to the AC distribution board at the front of the engine room. And that's how we get our battery power. And here we have the starboard battery room, 240 batteries, lithium-ion batteries.
A motorboat, it might do 17, 18 knots as its maximum speed, but majority of the time a motorboat is cruising at 12 because that's the optimum for fuel consumption and everything else. So for us to be able to do that and regenerate and not use fossil fuels is very cool.
Currently, the team are looking to add solar panels either to the superstructure or flexible ones in the sails. And the ship has already been pre-wired to accept both options.
I think the ambition right at the beginning was to be the first and set an example to our industry. And commercial shipping is taking it very seriously.
Beyond yachting, the Dynarig can move into the commercial side of shipping. There's already many studies done for having multiple Dynarigs placed on large ships.
And a sailing boat can go everywhere a motorboat can go. Just nicer, quieter, and no pollutions.
Now, the good news is The International Maritime Organization, the IMO, has set an ambitious target to reduce greenhouse gas emissions by at least 50% by the year 2050. Now, some shipping companies have gone beyond that with more ambitious targets to be carbon neutral by that year. But to make it happen will require a radical transformation. Let me give you a few shipping facts to set the scene, to show where shipping is at the moment. Over 90% of world trade is carried across our oceans by anywhere up to 90,000 large ships. The fuel burned by many of these ships is called heavy fuel oil. That's a toxic sludge that's highly polluting. Shipping, however, is the most efficient way of moving large quantities of goods around the world, by far. Now, obviously, we can't change things overnight. So we need to be looking at transition technologies, ones that take into account that very few people have retained those skills to operate traditional sails. We need to be looking at modern solutions.
Just 40 miles away from where Black Pearl is currently moored lies the Marine Research Institute, Netherlands, better known as MARIN. It's a world-renowned organization which for over 80 years has provided the maritime industry with expertise and independent advice. Today, they are at the forefront of research into sustainable marine propulsion.
One mistake that many people do is to think that the wind is pushing a sail, and that's why it's hollow, and that's why you're going forward. Actually, it's working with suction, not with pushing. The wind is blowing. You have a flow coming on a given object, and this object is diverting the flow and creating on one side a high velocity and on the other side a lower, smaller velocity.
It's known as the Bernoulli principle, after an 18th century Swiss mathematician called Daniel Bernoulli. He discovered that the faster a fluid flows, the lower the pressure. It's why a wing creates lift on an aircraft. The shape of the wing makes the air flow at a faster speed on the upper surface, creating lower pressure and effectively sucking the wing upwards. In the 1980s, designers began experimenting with rigid wings on boats.
So it started with simple, smaller sails in area, but with a metal rigid profiles. And then some engineer pushed the idea further and only looked at the way a lifting surface is working.
Collaborating with the famous undersea explorer Jacques Cousteau, two French engineers came up with a rigid sail which had a perforated outer surface and inside a fan, which created suction affecting the boundary layer. This amplified the pressure difference and increased the lift effect, making it 4 times more effective than the best conventional sails of the same size.
And people who are looking at traditional sails cannot believe that a pillar, just a round thing, can produce lift. But it's a very smart and very powerful system. And then this invention was just left on the side and never used again. 5-6 years ago, we made presentation to try to revive the idea because we were believing that was a very smart system. And my hope was that at least one person in the room would raise his hand and say, well, this is a nice idea, I will pick it up and apply it on ships.
One man who did just that was Frank Neuwenhuis.
We first started on scale models. The first one I took on top of my car in order to see if this suction is actually working. There's quite some technology to combine an airplane wing, which is only the wind always comes from one side. And in sailing, sometimes it comes from one side, sometimes it comes from the other side. Also, the suction technology is quite difficult, and we needed to get that all in the right balance. And of course, all of this we wanted to get ready as quickly as possible.
What they really needed was access to an immensely powerful computer able to handle the hugely complex calculations associated with airflow, and pressure. Luckily for them, just such a computer is to be found at the Marin test facility.
We have been working with them on calculations to further optimize the profile, the amount of suction you should apply to boost the performance, the effect of the height of the sail.
And then they studied how does this suction work, how does the angles work, and what is the right shape, and they've been extremely helpful.
But even with access to a supercomputer, you still need to conduct physical experiments. And if a car worked for a small model, there was no reason not to try it with something a little larger.
Our approach is to have a little bit of saving on many ships. And we try therefore to make systems that can be installed on the ships that are already out on the sea today. We don't have to wait to build new ships. And if we want to save quickly in shipping, we have to install something fast and easy, things that are produced on an industrial scale that gives you a result. One of the key issues of this wing is that this big ventilator is sucking out the air from the wing, and by that influencing the airflow around the wing. And it's done through these little holes here, which run all the way through the wing, and this ventilator just expels the air and throws it outside in the bottom, creating vacuum in the wing and influencing the airflow around the wing. So one of the most challenging things, really, is to get this big ventilator, 2,500 kilos of steel, inside this wing construction. And it has to be glued in and connected to the bolts here. And once it goes in, we only have 10-15 minutes before it has to be perfectly aligned.
One of the first ships to adopt the system is the freighter Anki.
You can push the start button and it will sense where the wind is and it will position itself correctly relative to the wind. This wing can actually tack, as they say in sailing. So depending if the wind is on the left side or on the right side, we change the shape of the wing and the boundary layer is being sucked away from the other side. And if you suck away this boundary layer, then you influence the rest of the airflow.
And with the sails in operation, the captain can reduce engine power and still maintain the same speed.
When the ship changes direction, the wings are following the change of the direction. They will always keep the same heading towards the wind. So the captain doesn't have to do anything other than to decide he wants to sail or not.
The system's already proven itself to be both rugged and effective. From the tempestuous seas off the African coast to the Arctic conditions of Northern Europe.
Best as any sailor knows this, that when you have half wind, so the wind comes from the side, then the effect of wind propulsion is the best. But when it's from 25 degrees to about 180 degrees, it works.
But Frank and his team weren't finished there. They had the idea to make something altogether more portable.
So, this is where the magic is going to happen. This is the container. There will be one wing here, and there will be one wing down here, and in the end they will open up and start saving fuel.
This is the MS Royale, a container barge plying the route between Amsterdam and Harlingen.
So what happens is, with a normal crane, they put the container on the ship, and then we press a button and the wings flap out. So at that moment it's already installed.
Which means that any ship with the space for a container could theoretically install a system quickly and easily. The team at Econowind estimate that in optimum conditions, a ship could reduce fuel consumption by as much as 25%. However, as the wind is not always consistent, they predict a still impressive average saving of around 10%.
In maritime sector is pretty conservative. for good reasons. I mean, the sea is a very harsh environment, so it's difficult to introduce innovation in the maritime segment. So I'm extremely happy to see that this very smart invention is now applied again on board ships.
And we're actually discussing now about a system. It will be 20 meters high. One wing will be about 2.5 times the total force of the 2 wings which are in the container.
What we need for wind propulsion to be taken seriously is not just 1 or 2 companies out there doing it. We need a vibrant, thriving industrial base with many companies delivering many new technologies.
This is the MV Copenhagen. Together with her sister ship Berlin, she operates on the busy route between Rostock on Germany's Baltic coast and the Danish port of Gaza. Built in 2016, they're 2 of the largest hybrid ferries in the world, able to carry 1,300 passengers and 460 cars.
Well, welcome to the battery room of the hybrid ferry Copenhagen. A hybrid ferry is a ferry that has a battery system installed to supply energy when it's needed and to store energy when it's not needed.
Scanlines estimate that their hybrid systems reduce CO2 emissions by up to 15,000 tons a year, the same amount as produced by over 340 average German households.
And the journey doesn't stop here. It is our overall ambition to operate zero-emission ferries, but due to the energy requirements for a 2-hour voyage, it is much more complicated, and all of the small things that add up.
As efficient as she is, Copenhagen wasn't originally designed to make use of the free and abundant energy that wind provides. But tonight, all that is about to change. Once the passengers leave the ship, she'll make her way to the nearby dock and be fitted not with a sail, but with a device first conceived of over a century ago, which works on a principle known as the Magnus effect. The Magnus effect gets its name from a German physicist named Heinrich Gustav Magnus. In 1853, he was investigating the reason why spinning objects traveling through the air, such as a spinning ball, don't move in a straight line, but actually follow a curved path.
So what you have, for example, on a football, you have a forward velocity of your ball, which is rotating, and the flow sees 2 patterns. On one side, a high velocity, on the other side, a low velocity, so a lower and a higher pressure, and through the pressure difference, you have a side force. And that's why, with spinning a ball, you can give a certain trajectory. If you take a mast, a vertical cylinder, which is rotating in wind, you will have the same effect.
In the 1920s, a German aircraft engineer named Anton Flettner, with a little help from a certain Albert Einstein, came up with the idea of using just such a device to propel a ship. By 1924, they'd retrofitted a schooner with 2 rotors driven by an electric motor, enabling it to travel at 10 knots. Having proved the concept worked, they went on to create a 3-rotor freighter. But the Great Depression, an abundance of cheap fuel, and no pressure on carbon emissions meant the idea was all but doomed for decades. But there was one legacy. Even today, these spinning cylinders are still called Flettner rotors. It's just such a device that's to be fitted to the Copenhagen. But this mega rotor is twice the size of those originals. Standing 98 feet high and 16 feet in diameter, it's built by Norsepower, a Finnish company who specialize in this technology.
It's an exciting day
even with careful planning for months, there's always something you can't perhaps see in advance. One angle to it is that we have people speaking 3-4 languages and people from 3-4 nationalities working together here.
The reason why Copenhagen and Berlin are the perfect ships for this, and in this case we are trying it out on Copenhagen, is because our ships are trading north-south and the predominant wind is westerly wind. So the wind, to have the best result out of a rotor sail like this one, the wind should be perpendicular to the direction of the ship. So it is the best conditions to test something like this.
But for the system to be effective, it must be commercially viable. Such a valuable financial asset as a large ship cannot afford to sit idle while engineering work is carried out. Even now, trucks booked to travel on the Copenhagen the following morning are already driving across Europe to meet her. For the installation team, it's going to be a race against the clock. To enable the operation to be completed as quickly and as efficiently as possible, the team from Norse Power have already installed the steel rotor foundation along with the control system and power supply.
With this massive piece of equipment, we need to be extremely careful that everything is done right. I had a long checklist that I went through line by line to make sure that everything is correctly attached.
Weighing 42 tons, precision is vital. The placement of the rotor has to be millimeter perfect to enable it to fit correctly to its foundation.
The rotor produces such massive forces that it needs to be connected with 100 really big bolts.
It's a job that can only be undertaken by a crew working inside the rotor. These bolts will need to cope with the 300 kilonewton force the rotor could potentially generate. That's the equivalent of the pressure of over 30 tons being acted upon by gravity.
We are extremely excited to finally see this project become a realization now. And to me and my colleagues, this is a way of really showing that there is a way forward other than burning fossil fuels out of our funnels, because it's extremely visible.
The team will now work through the night connecting the electrical system and tightening bolts. And tomorrow, the testing will begin. If successful, it could mark a new era for Scanlines, whose combined fleet transports 7.5 million passengers and over 2.5 million vehicles every year. But the team at Norse Power are well aware that many other shipping companies around the world will be taking a very keen interest. But some ports present certain challenges to the concept. Challenges that must be overcome if Flettner rotors are going to be adopted universally. At a test facility on the windswept coast of northeastern England, British company Anime have developed a system to address just such problems.
The Anime journey began over a decade ago with an environmentally driven ship owner and a group of shipping professionals who embarked on a mission to develop technology that would benefit the industry through reduced emissions.
It was a program that would take place across the world and involve extensive investigation into the way wind flowed around a ship's infrastructure. It was during this period that a renewed interest in the potential of Flettner rotors began, and work was undertaken to develop an automated system compatible with the demands of 21st century shipping.
The initial testing involved scale model testing with use of wind tunnel and 25:1 scale models at Southampton Warsash Academy, where actually the scale model vessels managed to reach a speed of 17 knots with no engine power on the lake tests.
It was an invaluable proving ground. This renowned training facility attracts ship's captains from around the world because the handling characteristics of these large models perfectly mimics their full-size counterparts. Having perfected the theory, Anami's decision as to where to put it into practice certainly can't be described as the easy option. They chose the bulk carrier market.
When developing solutions for these ship types, the crane operations govern so much, so having a large static structure on the deck of the ship would not be an idea that you could sell to anybody.
A folding rotor was one of a number of options developed, and being able to test prototypes such as this one for prolonged periods of time has provided a wealth of essential performance data.
The maximum RPM of this particular rotor you can see in the background is 450 RPM. Now, the relationship between wind speed and rotor RPM is quite important in terms of the performance. The surface speed of the rotor typically has to be somewhere between 3 and 5 times the wind speed. That's pretty much the general target.
But the owners of the 64,000-ton MV Afros needed something even more flexible. They needed the ability to actually move the rotors.
So we developed a new solution which enables the rotors to be transported along the deck, forward aft, to avoid cargo operations.
The system employs a series of trolleys on rails. When the ship is loading or unloading, the rotors can be moved into positions which best suit cargo operations, whether that be offshore or in port. Upon leaving, the rotors are then moved into their operational position and mechanically locked onto the deck.
The system is very easy to operate for the crew on board. The system takes care of most facets of the operation, including starting and stopping, choosing what rotational speed to go at, which direction to rotate in. Effectively, the crew can turn the rotors on leaving port. The control system will take care of everything. So for the crew, it's a very simple task. So Flettner rotors provide most thrust in stronger winds. So our rotors have been designed to operate safely in wind speeds up to 35 meters per second, which is a very strong wind. They have also been designed to operate in heavy weather, so when the ship motions are quite large. The wind direction also plays its part, and the ideal wind direction is from the beam of the vessel, so coming from 90 degrees or just behind. In those conditions, strong winds from the beam, you end up with very high fuel savings.
And savings in fuel means a corresponding reduction of emissions.
We believe that the savings can be anywhere between 5 and 30%, depending on a number of variables. I think in shipping, as you've seen with the wind industry and the wind turbine industry, bigger is proving to be better. But with ships, there are limitations on operation, so there will be a ceiling of where you can go with wind propulsion. But I don't think we've reached that ceiling yet.
Back in the Baltic, the new silhouette of the MV Copenhagen has been drawing much attention in the shipping world. The rotor installation was scheduled to be completed in just one night. With the ship needed in service the following morning, there was no margin for error. Remarkably though, the team was able to meet this ambitious target with room to spare.
It didn't last more than, I will say, 10 hours or so. Then the rotor was on, bolted, and we could go again.
At the moment, it's the height of summer when the prevailing winds are at their lightest. But the crew have wasted no time in testing the system ready for when the winds become stronger.
Of course, the idea with this rotor is that it's fully automatic. So normally we do not have to do anything. It just runs in the background. We have done some testing to prove the efficiency. On a cruising, we have been stopping the rotor, see what will happen. And we realized that the ship speed went down with half a knot. Then we started again, and we gained the half a knot. So it actually works.
We still need to see the good season for it. But we have already seen promising results. With installation of this rotor, the expectation is that we will save up to 5% on our fuel oil. But a 5% fuel saving is also a 5% emissions saving.
Although the rotor may be huge, its control panel is remarkably small. It not only automatically controls when and how fast to spin the rotor, but it also provides valuable data about all aspects of its performance. But how has such a large addition to the superstructure affected the ship's handling?
We feel a little difference. It's not much. We can see when the rotor starts, then the ship will heel a little. In high winds, it will heel more, up to 2 degrees, we have seen. So the one thing we have to do every time the rotor starts is that we have to move some ballast water. So for our customers, they will not notice because the ship will always be even keel. And we can see when we have high winds in Gedser, our smallest port, we also feel that we have to work a little more with the maneuvering.
In the same way that a wheel of a car requires balancing to avoid vibration, so the giant spinning rotor has required a little fine-tuning as well. But that has been finally completed today.
Now when we have made the last corrections, that makes it possible to run even faster, the most optimum speed with the rotor.
We acknowledge it's a technology that has been around for 100 years, but so far very few commercial operators have had the courage to actually try it in a live environment. We sincerely believe that we are in the right spot. We are the right size of ship to make this a success. I can't explain how thrilled I am to be given the opportunity to run a project like this, to be allowed to do things that are good for the environment. It's good for the company as well, and it draws a lot of positive attention, we have to say. It is fantastic in all respects.
But it's not just how ships are propelled that is currently undergoing a revolution. It's also where they sail and when.
In the 21st century, we have advantages that even 50 years ago would have been unthinkable.
By making use of ocean currents, it's possible for ships to make significant energy savings. But how do you monitor these ever-changing currents in real time in order to be of use to ships' captains?
So our system is about measuring ocean surface currents by observing how the vessels, ships are behaving, how they move around, and we do that by analyzing marine traffic information. So every single commercial vessel has a beacon which broadcasts real-time its position, its speed, and some information. It's called AIS, Automatic Identification System, which is to avoid collision between vessels. We utilize 120,000 vessels continuously sailing around the world and sending their position every 2 minutes. And this information is collected by some telecommunication satellites, and we get this data into our server and with our processing system. So we learn with some machine learning algorithm from the way the vessels are behaving. And we deduce the ocean current that the vessels are going through.
And with access to accurate information about currents, ships' captains can alter course to either avoid adverse currents or take advantage of favorable ones. It's estimated that if applied to shipping globally, it could reduce fuel and emissions by 5%. However, on some routes, those savings can increase to as much as 15%. And this is just on conventional powered ships, without taking into account the additional benefits that wind-assisted propulsion would bring. But for global industries which have grown used to a just-in-time delivery of parts and materials, there are still huge questions to be resolved if we are to achieve a new, greener future.
What if there's no wind, or the wind's blowing in the wrong direction? Well, in that case, we need a hybrid approach.
This is Energy Observer, a French vessel which is halfway through an extraordinary 7-year odyssey.
Energy Observer is a floating laboratory. The idea is to test different technologies constantly and improve them, and to work hand in hand with the maritime industry to help them find ways to limit their impact. It's also a media boat, so the idea is to be able to communicate and educate people about renewable energy everywhere we go. So the boat evolves all the time. It's a work in progress.
The project is the brainchild of master mariner Victorien Erissard and journalist, filmmaker, and explorer Jérôme Delafosse. And the boat, reflecting the ethos of the mission, is of course recycled.
Energy Observer was built in 1983 in Canada. Her first name was Formultag.
And it was one of the first big racing catamarans. And it's basically a boat that we completely refitted. I mean, the boat was a wreck when we got it.
Turning a racing machine into a laboratory meant doubling its weight to 30 tons, which in turn required putting in extra foam to keep it afloat. But it was necessary as it gave the boat the ability to install, test, and adapt a wide variety of technology. But as with all experiments, it's often as useful to see what doesn't work.
For example, we try the vertical axis wind turbines, and I think it's not a solution for this type of ship.
Other things have worked so well that the decision was taken to increase their use.
At the beginning, we had only 100 square meters of solar panels, and now we have more than 200 square meters.
The good thing about Energy Observer is that they're prepared to try new approaches, new technologies that may not be ideal for them, but could be solutions for others.
The kite system is a solution, but it's not a solution for us at the beginning because we sail along the coast, along the European coast, and is a solution for the offshore navigation, for example, when you cross the Atlantic. And after, we want to try another technology, and it's impossible on this ship to keep all the technology because after the weight is too important.
While kite sails may not have been ideal for the Energy Observer, they are being tested on larger ships. One benefit being that they're an off-the-deck system. An off-the-deck system means they don't take up valuable deck space, which could be very beneficial for things like container vessels.
Having now been fitted with highly efficient rigid sails called ocean wings, Energy Observer can use its propeller and electric motors to generate electric power while sailing, much like Black Pearl. However, what has got so many in the maritime world excited is what they do with the electricity they generate.
With that energy, we take seawater, we desalinize it, we demineralize it, then it goes through an electrolyzer, which divides the molecule of water into H2 and oxygen. The oxygen we let go, and then we'll be compressing the hydrogen in 8 tanks, which are at the front of the boat.
And this ship, Energy Observer, she's the first ship able to make her hydrogen on board.
Working with Toyota, they installed a new highly efficient hydrogen fuel cell, which uses the hydrogen they create and store to produce electricity, which can then be used to power the electric motors.
The maintenance of this type of technologies are very, very easy. You don't have oil, you don't have noise, you don't have fine particles everywhere on the ship, so it's very clean. It's really the future.
When we started Energy Observer, the maritime industry was kind of laughing at us. I mean, they were like, yeah, whatever. I mean, this is just, it's peanuts, it's never going to work. But because we've proved the energy mix that we've implemented on the ship works, they're really interested. And now they're like, oh, so how can we have hydrogen on board? How can we add solar panels? How can we reduce our emissions by using the ocean wings, for instance? So we're only at the beginning of this phase, but it's very, very exciting.
So successful has this project been that it spawned Energy Observer developments, which is creating a range of commercial applications based on lessons learned. From hydrogen generators to floating green hydrogen fuel stations. But the crew know from first-hand experience, it's a race against time and one that none of us can afford to lose.
When you see the glaciers, it's absolutely breathtaking. But at the same time, you know that the polar bears are all dying, that the glaciers are all melting. So you know how fragile they are because they're all disappearing as we're exploring.
Thanks to the efforts and research of just such pioneers, there are now many in the shipping industry that are daring to believe that the next decade could be one of transformation.
So a lot of people ask me, is this really going to happen? Is this not just a fantasy? Well, my answer to that is it's already happening. Year on year, we're seeing momentum growing, a doubling of installations every year, and that trend is set to continue.
Really, it's not only a transition, an energy transition pattern, but it's really a revolution. So we are going to see new type of ships, but what people will mainly see, I think, is the fact that a large wind power device will be installed on board ships. The bigger the better. If you want to catch a lot of wind, you will need at the end quite some area. There might not be sails like the Cutty Sark, but I think this will be quite welcome by everybody to see sails again on ships.
Can wind do the heavy lifting on its own? Of course not. Alternative low carbon and zero emissions fuels are really going to be necessary too.
We know that we will need different types of power, so the new vessels will be much more complex, I would say, in terms of design and engineering, because they will have to cope with different sources of energy. You will have to handle them smartly, typically with the wind, because the shortest route will not be the best route.
It's been estimated that by 2050, wind could provide up to 1/3 of the energy required by the maritime industry, with some new designs on certain routes getting as much as 80% of their energy from the wind.
Well, by 2050, we could be seeing vessels that have far more hydrodynamic and aerodynamic hulls. The hull itself functioning as a wing sail, perhaps. We will be seeing things like kites and suction wings being standard equipment on vessels.
We need to dare to go ahead at very high pace. So that means also taking risk. But we have no choice. It has to happen, and it has to happen extremely quickly. At this moment, in terms of climate change or loss of diversity and all the issues related to human activity, I mean, it would be hard to make larger mistakes. The basket of solutions that we see coming for shipping will allow to transport goods from A to B on the planet without producing any harmful emissions. And this is a very nice horizon, not only for the shipping, but for all mankind.
If we are to stand a chance in our struggle to limit global warming, a change in the way we travel will be essential. Transportation accounts for 24% of global CO2 emissions. And in the US, that figure is 29%. The vast majority of it comes from what we drive on the road. Our relationship with the automobile has been a defining feature of modern life. But as we make the transition to electric power, many experts believe that the nature of this relationship is about to undergo a revolution. Without doubt, this presents a challenge, but it also presents the opportunity to redefine the way we travel. No stranger to thinking differently about how we use vehicles is Robin Chase, co-founder of Zipcar, one of the world's leading car share companies, and Venium, a data network company that is helping to support what's known as the Internet of Moving Things. She's worked with institutions and authorities around the world, developing innovative transport strategies.
I think of transportation as our gateway to opportunity. Whether you want to be educated, see friends, have a job, be healthy, go shopping, everything resides upon, can you get there? How much time, how much effort, how much money. It is the glue that makes our entire lives possible. So the idea that there's one type of vehicle or one type of mobility solution that will service all of our needs is craziness. And that was what happened in the last century. When people buy a car, what happens is they think about their largest use case. They think, oh, I need to have it so in August I can take my family on some big trip with everything in back. But in reality, 70% of our trips are us alone in the car. And 50% of our trips are less than 3 miles or 5 kilometers. So the reality is, it's us moving alone by ourselves for the vast majority of our trips. And cars, whether they're electric or not, are vastly oversized for what we're actually doing.
This is the Aptera, soon to be the most aerodynamic production car in history. With a potential range of 1,000 miles from a single charge, it's convinced over 15,000 customers to place an order before a single vehicle has rolled off the production line. But this is not the product of an automotive giant. This is what happens when some engineers from San Diego take an uncompromising approach to efficiency. The Aptera story started over a decade ago, when electrical engineer Steve Fambro, sitting in traffic during his daily commute, became convinced that there had to be a better alternative to existing cars. Something more efficient, and certainly something more sustainable.
So I started building this car just as a hobby. And at some point, the light went on where I thought, if I could get paid to do this, I would do this all day. So I started thinking about, well, what would that look like? What is that? Well, it's a startup car company to sell the most efficient vehicle in the world.
And then Steve met Chris Anthony, an entrepreneur who was building composite wake boats, who not only shared his passion, but was also prepared to think differently.
And it was off to the races. It was really bizarre how quickly it all happened.
Well, you know, when I first met Steve and he explained the math equation for why typical vehicles use so much energy, the first thing that he brought up was a typical Toyota Camry type vehicle will use 60% of its fuel just pushing air out of the way. And it instantly struck a chord with me because I was a hydrodynamicist and I'd done lots of simulation work and worked on how fluids work. And I said, yeah, I get it. That's a problem. And he said, I think that we can build a vehicle that takes that aerodynamic drag almost down to zero. Perfect, sign me up, let's build that vehicle. And we didn't start with a marketing study or a focus group. We started with the engineering problem of how do you make transportation more efficient? And then we just ticked through the boxes on what would make the most efficient vehicle platform. And what you end up with is something that looks like what I have behind me.
When I first started looking at low drag shapes, I thought, well, let's look at the streamliner hot rods from the 1950s and 60s. You had a lot of veterans who returned after World War II and were taking aircraft parts and drop tanks and turning them into hot rods and then taking them to the salt flats and seeing how fast they could go. And for the amount of horsepower and the size that they were, my back of the napkin calculations said that they should have been able to achieve much higher top speeds because of the streamlined shape. What I didn't realize, and I guess maybe what they didn't realize at the time, is that a perfectly symmetrical streamlined shape has very low drag in the free stream, up high in the air. But when you bring it close to the ground, it has a completely different effect. In ground effect, it becomes a much higher drag shape. And so to make a streamlined shape, but that's also low drag and ground effect, it looks different. And as it turns out, lots of creatures, fish, catfish, sharks, etc., that swim in the free stream, when they get down near the surface, they will change their body shape to lower their drag. And the reason they lower their drag is because nature hates inefficiency. Nature doesn't do anything inefficient. It's all about saving energy.
So sharks really taught us a lot about how things work in ground effect. So that's why the Aptera looks a lot like a fish or a shark swimming close to the seafloor with a hump in its back.
Before we went out fundraising, we said we need to have some third-party seal of approval. Who could we get to also examine the shape, maybe put it in their wind tunnel, give us a thumbs up that it is low drag. And so we hired a NASA Langley low-speed wind tunnel. And we had a conference call with them, and you could hear all the scientists on the conference call. And they're like, this is the lowest drag road vehicle we've ever seen. Like, what are you guys doing? How does this work? And we said, what? We hired you to tell us how it works. You're NASA.
What has enabled the team to fine-tune their design in a way that would have been impossible a decade ago are the advances in computational fluid dynamics. This is a computer tool that can accurately analyze complicated aerodynamics and airflows.
We bought a lot of servers. This is after we got our funding, and we ran CFD 24 hours a day for virtually every shape that touches the wind in the vehicle.
The processing power that you can put to these problems now is just immense. We can load a full vehicle model into our simulation deck and run it on a web server and have results in 4 hours now.
Incredibly, the entire Aptera car has less aerodynamic drag than just one side view mirror that you'd find on an average American pickup truck. One aspect of the vehicle's design that often draws attention is the fact that it only has 3 wheels.
We determined that if we got rid of the rear wheel, one, we don't really give up any performance characteristics, but we gain in aerodynamics, we lose some weight from having the structure to hold that extra wheel, and we have less rolling resistance. So you have a certain amount of weight that's deforming the tire constantly on every revolution that you ever drive, So if you can decrease the amount of traction patch on the road, you get better overall efficiency.
Our vehicle can go around the track as comfortably and as securely as any comparable four-wheel vehicle.
And one thing crucial to its stability is its center of gravity, which is greatly helped by the choice of powertrain.
How we power the vehicle is actually through the wheels. The motors are designed into the wheels. It takes the weight and puts it out at the corner of the vehicle, so you have a better center of gravity, which gives you more torque, so you get better 0 to 60 time acceleration, and it gives you more regen capabilities, so it saves your brakes and gives you better overall performance. Weight is crucially important to our efficiency, so the more we can reduce weight, the better.
And one of the heaviest parts of an electric vehicle is the battery.
Well, batteries are the most expensive part of the electric vehicle. And so if we can fundamentally reduce the number of batteries necessary to go from point A to point B compared to any other electric vehicle, then we're able to offer something that costs less to make and costs less to sell.
The combination of less weight, reduced rolling resistance, and world-leading aerodynamics means you need less energy to power it.
With 100 watt-hours per mile energy usage, you can do things like charge with a regular extension cord from your garage. The same cable that you charge your cell phone with is a cable that you can charge the Aptera with up to 200 miles overnight. Also, you know, if you're on a trip and you go to one of the roadside chargers, you're charging 4 or 5 times faster than any EV around you.
But the Aptera has one more energy-saving trick up its sleeve: its solar-powered charging capability. All the more pertinent given the US Department of Energy's predictions that electricity consumption is set to increase by as much as 38% by 2050, in large part because of electric vehicles.
We have a 700-watt solar panel on our roof, and that can produce over 4 kilowatt hours of power per day in sunnier places. That's 40 miles of free driving per day just because you parked it out in the sun.
But for most Americans that drive less than 40 miles a day, 60 kilometers or so, you wouldn't have to plug it in. And the reason why it's even feasible is because the vehicle is so efficient. So if you were a big electric truck manufacturer or sedan with lots of batteries, you could cover the whole thing in solar and you might get 5 or 10 miles of trickle charge. Whereas if you can account for most of the daily miles from the sun without taxing the grid at all, then it makes it much easier to deploy electric vehicles across a wide area.
It really is just striving to build the best production vehicle we can for the people that have reservations out there.
Possibly the biggest changes this automotive revolution will have on our way of life will be felt in our cities. Michael Hurwitz understands the task ahead more than most. He worked for the British government, where he was the most senior official responsible for energy and transport. He then spent 5 years as Director of Innovation at Transport for London, one of the largest transport authorities in the world, responsible for managing the city's public transport network, which includes 9,300 buses, an underground system handling 5 million journeys per day, and main roads with over 6,000 sets of traffic lights. He now works for Arrival, one of the new generation of automotive companies that are bringing a fresh perspective to introducing electric vehicles into our towns and cities.
It is now absolutely certain that around the world, cities, regulators, national governments are going to require an increasingly rapid shift to zero emission. Mostly electric, some keep an open mind to things like hydrogen, but it is happening, and it's happening at an increasing pace. There's an interesting point about whether the incumbent industry, the traditional automakers, can transition fast enough. Some people aren't as ready, but we feel that we're kind of ahead of the curve there.
When Denis Svedlov decided to found Arrival, It was because he felt it was not just the type of vehicles that needed changing, but the entire auto manufacturing model.
That is not enough, because we still get vehicles which are expensive and that are not sustainable. You don't need to have a compromise between being green or being efficient. And that's why we started Arrival in January 2015 with the idea to reinvent the way vehicles are made.
But where to start? Well, for Dennis and his team, one particular sector above all stood out: commercial vehicles.
These are the vehicles that are being driven 8-10 hours, day after day after day. If there are any vehicles in a city that you'd want to replace with zero-emission vehicles, it would be these commercial vehicles.
One of the aims of Arrival is to be able to work with companies and create a bespoke vehicle specifically targeted to their needs, which is exactly what they've been doing with UPS, with whom they have jointly been developing a new delivery van. But how will this new startup company compete on price with established automotive giants who spent over a century mastering the production line and economies of scale?
I think the real opportunity with a startup, with a new company, is you don't have any of those existing assets. You can set off in a completely new direction.
The approach that Arrival has taken can in many ways be encapsulated by the words of the influential 20th century economist Ernst Friedrich Schumacher.
He wrote something along the lines of, "Any intelligent fool can make things bigger and more complicated, but it takes a lot of courage to move in the opposite direction." I love this quote. It really captures our DNA, what we do here, how we develop things.
Large automobile factories can take years to build and have a price tag of over $1 billion. Arrival believe that for just $50 million, they can take over an existing warehouse and within 6 months be able to produce 10,000 vehicles a year. Able to be built all over the world in locations where the vehicles are needed, they will employ local people, pay local taxes, require less infrastructure, and be able to provide specific models suitable to that location. They call it a microfactory, which instead of housing a conventional production line, uses a collection of robotic cells.
And we have a whole array of these cells that do different operations. But the key to it is how we link them together. We link them together through mobile robotics. So literally a little wheeled robot that carries parts and vehicles from cell to cell.
I've been building robots since I was a kid, right? From toys. I was fascinated with robots. I was fascinated with the spacecraft. So all my studies over the years were focused on this: space exploration, robotics, and AI. I met Dennis after having worked on a space mission for the European Space Agency. We discussed about how to use technology to have a positive impact on people. And we liked each other, and I jumped on board. I left the space program and I joined Arrival.
Where once in the traditional automotive industry, it was tool makers who were crucial for the implementation of mass production, today a different type of engineer is at the heart of this new way of building vehicles.
More than half of our people are software engineers. We are strongly software people. What this means is that we spread intelligence in every robotic asset that we have on the shop floor. These robots sense and perceive the environment. They gather the data, they process it in real time, and they use this data to execute operations in real time. If something changes in the environment, they react. And then we have an operation control system. You may think about it as the overlord of the factory, right? The AI that runs it. And this system gathers continuously information from all the children, from all the robotic assets on the shop floor. We have done a lot of work on computer vision, and we've developed something quite unique. And our systems are capable of understanding the position of an object, classifying that object, understanding the position in 6 degrees of freedom, so in space, in any location, a sub-millimeter accuracy. These are robots that can navigate autonomously in the environment, can avoid obstacles, can detect any anomalies in the environment, and can react dynamically, and also work together. These robots can connect to each other to create a larger platform that can transfer bigger and larger payloads.
But as clever and sophisticated as the system is, if the microfactory concept is going to work, it'll need the right materials to work with.
I'm going to be a bit biased here, in that I think materials are like foundational to a lot of this. If you're going to manufacture something anywhere in the world, then you can go one of two routes. You can either source in one place and transport it, or you source close to where you're making. And our strategy is very much to try and source as close as we can to the factories to support local communities, local economies, and to build relationships in those areas. So if we want to be able to build a microfactory anywhere, on a high street, in a warehouse, you have to start asking questions about the kind of materials that are going to go into the factories. They also have to be recyclable, because you need to be able to reprocess them wherever you are. You know, if a van's built in one part of the world, it should be recycled wherever it ends up. So, and that drives a certain type of materials logic.
In order to meet all these criteria, it was decided to use an aluminium chassis onto which would be put a body made from thermoplastic composites. Able to be molded into shapes when heated, thermoplastic composites differ to many other forms of composites because it's a process that can be reversed and repeated many times, making it perfect for recycling and giving the product an almost indefinite shelf life.
It's where there is a huge amount of innovation in the industry. We can process that by 3D printing, so we can make prototypes. We can turn it into injection molded components. We can process it into compression molded or extruded, or you can, make garments from thermoplastic materials. Like, it's just, the amount of opportunity of thermoplastics is just immense.
The company have developed their own composites, tailor-made for their requirements. Those destined for body panels arrive at the factory in the form of rolls of fabric. These are cut to size, layered, and molded into a variety of different shapes, and all done autonomously, using far less machinery and energy than a conventional automotive plant. And what's more, waste is eliminated because the properties of the material allow any offcuts to be recycled and made into other components.
Like, that's so fundamentally different from the conventional way of working. I mean, when people join the company, they often, it's quite mind-blowing. We are weaving fabrics and knitting, and there is no paint. The colour is throughout the panel, and you can recycle the whole panel at the end of its life.
Panels are also able to withstand impacts in a way that no steel equivalent ever could. All of which is of considerable appeal to commercial fleet operators.
Their vehicles are their brand that's rolling around in those communities day after day, so they always want their vehicles to look their best. They spend an enormous amount of money every year per vehicle to keep their vehicles looking so good.
This combination of versatile materials and a highly agile production process is also changing the way the company approaches its research and development.
So in regular R&D, I'm used to working on projects that are 2 to 4 years long. And here we're expected to turn around proof of concepts in a matter of weeks. If it takes longer than a month, then it gives us pause for thought. The point is to prove your idea as quickly as you can, and then that means that you can cycle through ideas much quicker. So the other core concept for us is that failure is not a bad thing. I encourage my team to fail as often as they can, because it's only when you fail that you either discard an idea and move on, or you keep learning.
This ability to utilize the AI software to transpose concepts into production has enabled the team not only to develop commercial vans, but also buses and rideshare vehicles. With a growing list of customers, Arrival has already set up one microfactory in the UK and 2 others in the US, with more planned for other countries in the pipeline.
In hindsight, some of the most revolutionary ideas seem obvious. And I wonder if people will talk about microfactories that way in a few years, for instance. I can't explain exactly why nobody's thought of it before, but it is clear that bringing together the right group of people on the right mission with the right set of objectives was an important part of developing this very different approach.
There are still many challenges that need to be overcome to successfully make the transition to full use of electric vehicles. Today, over half the world's population live in urban areas. In Europe, it's almost 3/4, and in North America, it's higher still at 82%. And these figures are only set to increase. Many towns and cities have road layouts that are hundreds of years old, meaning space for charging is at a premium. It's sobering to consider that 40% of Americans do not live in a home where they can use a personal charger. So while some have been tackling the issue of electric vehicles themselves, others have been wrestling with the problem of how to charge them. Back in 2012, the founders of Electrion, a Tel Aviv-based company, decided to investigate the possibility of creating a viable wireless system known as induction charging.
So we have one coil that we put under the asphalt, and we have another coil that we installed at the bottom of the vehicle, and actually we have a transformer. This is something that was found by Tesla 100 years ago, and we are using this phenomenon.
To fully understand how the system works, one needs to travel even further back to Michael Faraday's work on electromotive force. He discovered that in the presence of an alternating magnetic field, an electromotive force could be produced across an electric conductor. Nikola Tesla took this a stage further. He deduced that if an alternating current was passed through a coil, it would generate an alternating magnetic field. If a receiver coil was then placed nearby, this alternating magnetic field would induce an electrical current in the receiver coil. And if you have an electric current, it can be used to charge a battery. It was a brilliant concept, but sadly, at the time, there were no commercial applications. It would take another century for the principle to be adopted by charging devices in our homes. But for the system to be viable for large-scale vehicle use, it would need to be made much more efficient. When they started, it was estimated that almost half the electricity would be lost during the wireless transfer. But the team were confident that by fine-tuning all the various components, as well as the power levels and oscillation frequency, this could be dramatically improved.
So first, when we established the company, we focused on dynamic wireless charging, or electric road system. It means that we electrify the road and we charge the vehicle while the vehicle is in motion.
So this device is part of the R&D work. You can see here that this simulates actual vehicle driving on the road and being charged while driving. So those are the coils that are under the asphalt, and this is the receiver that is under the vehicle. Those coils are deployed under the asphalt about 8 to 10 centimeters. The coils emit energy to those receivers only when there's an authorized receiver that communicates with the coil, and then the energy is being delivered. Otherwise, those coils are totally passive.
So as a general rule, our wireless charging technology charges at approximately the same speed as any standard conductive charging solution that you can buy and use at home.
Having developed the theory, they built a 300-meter test track where they spent 3 years testing a variety of vehicles and perfecting the system to a point where it achieves an energy transfer efficiency of up to 91% in test conditions. They also perfected the system to charge static and parked vehicles.
It can be installed in locations where conductive or plug-in charging cannot be. So locations like bus stations and garages, inside city centers, underneath taxi queues or stands, directly under the loading docks at commercial facilities, and of course roads and street parking, for example, because there's no interference with the pavement or with the road. You know, everything can be underground.
With the ability to charge both moving and stationary vehicles, the next step was to put it into practice in the real world.
In Tel Aviv and in Karlsruhe in Germany, we have a public pilot on the roads there with the public bus operator in the city. And in both instances, we're demonstrating that with a combination of stationary charging at the terminal or at the bus station for a few minutes while the vehicle is parked, plus some small stretch of dynamic wireless charging along the route of the bus, is enough to power the vehicles so that they can run 24/7, and we can simultaneously reduce the size of the battery or the capacity of the batteries.
And it's this ability to reduce battery size that could be hugely significant as the number of electric vehicles on our roads increases.
There are about 1.4 billion vehicles on our roads today, globally. We just haven't found all of the resources that we require in order to shift to electric mobility on a global scale. There are issues around destroying habitats, for example, from mining for cobalt or for lithium ion. And so anything that we could do to minimize the impacts and to minimize the size of the batteries is probably going to be a good thing. In theory, we can reduce battery capacity by up to 90% as long as we have wireless charging in convenient and accessible locations.
In Gotland, Sweden, they are already successfully operating the world's longest continuous electric road system, stretching over 1.6 kilometers. It charges not only a public bus at the moment, but also a 40-ton truck. What's so significant about this trial is that it demonstrates the ability to simultaneously charge different-sized vehicles with different energy requirements.
The system is totally automatic, so the driver actually doesn't need to do anything, he just needs to drive. We have a metering device inside the vehicles, so this is how we know exactly how much energy every vehicle consumes.
Each 100-meter section contains 60 charging units, each able to charge an individual vehicle, meaning that volume of traffic will not be an issue. It is hoped that in Europe alone, there could be at least 14,000 kilometers of such roads by 2030. But what sort of disruption would installing such a network cause?
Of course, we're not suggesting that we would come into any city and tear up all the roads in the city. We're looking at finding strategic locations where it makes sense to deploy because you have enough heavy traffic. So if you looked at a city grid, for example, you'd be looking at deploying somewhere between 15 to 30% of the main roads.
If deployed at scale, the team estimate the costs to be around $650,000 per kilometer.
When we established the company, we had a mission to deploy 1 kilometer within 1 day. And actually, it was a joke 9 years ago. But today, we can show that we did it twice, in Tel Aviv and in Sweden. Our goal is to pave a whole city in few weeks. And we are talking about a huge infrastructure project. And to do it in few weeks is a huge challenge. but I believe that we will reach that goal.
I think everyone has to accept a bit of change. It's a deep-seated connection to a personal vehicle that many people have. Many of us are going to have to let that go.
Without question, our relationship with the car and car ownership is about to change. But will it necessarily be a bad thing? In the United States, the country most synonymous with the car, over 10 million households already don't have access to one. And when combustion engines are finally phased out, will there be enough used electric vehicles available at a price people can afford?
Who is buying new cars? Who can afford new cars? Around the world, the average age of the car has been going up. It used to be around 9 years, and now it crept to 10, 11, now it's up to 12. The average age of new car owner is 52 to 54 years old around the world. Also, the economic burden on us is phenomenal. On average, and I was looking at these numbers in countries around the world, on average, it's about 15% of a household's budget is spent on their car. And that means when you go to work, the first hour and a half of your work is paying off how you get to and from work. Poorest 20% of us, it's 33% of their household budgets go to their car. And I was just seeing a study of the US that had counties highlighted, and there were some counties in which 80% of a person's income paid for their car. It's mind-boggling.
So when I was at Transport for London, you get to see day to day what is required to keep a city moving, and that's from the coordination of traffic, buses, the underground, ticketing, the cycle hire, overground rails. But one of the most fundamental questions is, how do you make what you provide work for everybody?
Many believe that by engineering our cities to work differently, we can create a sustainable, flexible, affordable, and convenient way to move about. It's called a multimodal model, which includes improving public transport, creating a safe environment in which to walk and cycle, and where the new electric micro-vehicles can fulfill those short solo journeys we now make in our cars.
How do you want your city to feel? How do you want it to look? How do you want it to sound? And from that, derive how you should behave in a city.
In many European cities today, and in the US increasingly, there's been this idea of the 15-minute city, which means that in my daily life, I will be able to walk or bike or go by subway in 15 minutes to get everything I need in my daily life.
But what about those times when only a car will do?
We do need cars sometimes. I am not anti-car. I have my 96-year-old mother. I am carrying lumber around. I have places to go that are far away. But it's not the thing that I want to own and use for every trip. The economic efficiency of not owning your own car is profound.
With concerns being raised about the embodied energy and the carbon footprint of electric vehicle production, particularly with regards to certain giga-scale battery manufacturing, could shared ownership be part of the solution? The notion of car share is well established, but how do you persuade people who are wedded to the convenience of having their own car to use them? Could autonomous cars that deliver themselves to your door be the answer? And just how good would the technology need to be? Not content with reinventing the factory, Arrival are also pushing AI technology in cars to a whole new level.
Hi, my name is Max Kumskoy. I'm a product lead of autonomous driving team at Arrival.
Max and his team are developing what is known as a full-stack autonomous driving system. A system which can operate without the need for maps or GPS tracking. A system that will rely on what it sees and senses. Autonomous vehicles typically rely on a range of sensors, including radar, LiDAR, which is similar to radar, but instead of radio waves detects reflected light, ultrasound, and cameras to be able to see things like road signs. From all this information, onboard computers are able to generate a 3D model of the vehicle's environment. And all of this has to happen and be processed in real time.
You think, all right, you're good. But how do you know that you're good? You need to test yourself against somebody who is already recognized as a top performer.
RoboRace was a championship started by Arrival's founder, Denis Fedlov, which allows AI teams from around the world to compete against each other to achieve the fastest lap. But for Max and his colleagues, this just wasn't challenging enough. In Rome in 2016, the Arrival team took on the American professional drifter, Ryan Turk.
And we saw the time, and it was just a disaster. The gap was just, unbelievable. We were like, well, we can do better, because actually computer has lots of advantages over human, and we were like, why are we not using it? What was just a fun bet now turned into a massive development of vehicle stabilization algorithms for autonomous cars.
They developed a series of algorithms to perform different roles. One to perceive the surrounding environment, including other potential road users. Another to determine which route or path to take. One for what speed to go, and one to actually control the car.
But that's not it. So you start driving, you are in motion, you're driving, and then, life happens. There can be a sharp corner, so your car can get out of control. So you need to have another algorithm that will actually detect that you are about to crash or about to do something dangerous and prevent or save the car from the situation.
When it came to testing their improved AI system, they decided to take things to a whole new level. Lucas de Grassi has been racing since he was 10 years old. Having graduated from Formula One, he went on to become one of the co-founders of Formula E and is now the most successful driver on the Formula E grid.
I think here the team has a big chance of performing really well. I hope I can still beat it, but deeply I want the team to be very, very fast.
The car was doing its best, but it wasn't changing its performance from lap to lap. And we saw that the gap with Lucas or with Ryan was huge. And we thought, all right, what is he doing that we are not? And we realized that he's actually learning. He's learning and adjusting from lap to lap. And that's when we implemented an additional algorithm that was learning. And that's when the car started to be faster from lap to lap. So it was taking into account everything it knew about the track from lap 1 to lap 2. Where can it go faster? Where can it go slower? That was a major point in our racing career. The car started to learn, and it was getting closer and closer to a human driver.
By analyzing all the performance data, the AI system can work out what it does differently each time, and if it makes it go faster. It then changes its driving behavior to reflect what it believes is the most efficient method. And over time, it's able to perfect this. By mid-2020, there was a palpable sense within the motor racing world that racing drivers were about to suffer the same fate as chess grandmasters.
First of all, I have 25 years of experience, while the AI have only 2 or 3 years. So that's a bit unfair. But we are both controlling the car in the same fashion. So you have only access to steering, throttle, brake. And you have to combine these three inputs to create the best lap time around the track.
It was time to test the new learning algorithm. Would it provide the extra edge needed to outperform Lucas? But just when it looked like a breakthrough was possible, Mother Nature intervened.
So I had a lot of fun out there. The problem is that there are patches of dry and wet. So some corners, the optimal line is where it's a little bit more dry.
Launching in 3, 2, 1.
The conditions haven't improved, and the autonomous car's new systems will be tested to the limit.
Whoa. And now it starts to rain again, so it's very hard to compare now.
Yes, good effort. That was amazing. I've never seen it correct like that before.
The autonomous car is definitely improving. But has it done enough to beat Lucas? Who knows whether the car could have won without the rain? But the team believe it's just a matter of time. The ultimate challenge for Arrival and for their robo-race team is to make the autonomous car smarter than a human.
You can spend a lot of time to teach one human how to drive fast and safe. You can spend a lot of money on his entire racing career. That would be one guy. How do you copy that knowledge to the rest of us? You can't, right? With the computer application, it's different. You take all the bits, all the knowledge from those guys, you put it to the code, and then you copy this code to all the cars. That's essentially what we're doing. We're learning from them, putting it to the code, put the code to car, and copy.
This is so important. This is so breakthrough from Arrival and from RoboRace. In a couple of years, the world will look back at what we are doing today as something that pushed this technology that eventually will change a little bit the world for a better, safer place in the future.
Autonomous vehicles are currently being trialed all over the world. Companies such as Zoox have created rideshare versions. Taxis and buses are also being intensively tested, and in certain cities, they are even being integrated into the public transport network. Looking into the future, some envisage AI technology being used on a grand scale to coordinate citywide traffic flow, with technology optimizing speeds and the changing of traffic signals.
Done well, I think autonomous vehicles are a spectacular addition to a multimodal lifestyle, but we have to make sure that we do not own those vehicles.
The concerns over privately owned vehicles is centered around their potential to actually make congestion worse.
With an autonomous vehicle, I don't need to park. Please let me out. You just keep circling. I don't care what you do. Doesn't bother me because it's gonna cost me nothing. I'll have my tea. I'll chat with my friend for an extra hour, and you come back when I call you. So that's hell. Heaven. So this transition to autonomous vehicles also comes with fitting into our multimodal lifestyle, where I can now have shared cars everywhere, even for people who live in rural places.
And then there's the issue of how us humans will react to seeing empty vehicles driving along on their way to pick up passengers. Will normal driving courtesies still be observed?
Yeah, that's a really big, so far unanswered question, right? You know, are people going to be kind to them? I think there's going to have to be a lot of work done to make people comfortable with the concept.
Our roadmap for achieving the electric dream may not yet be fully formed, but it is without question a journey full of opportunities, provided we have the courage to grasp them.
So when I was in central government, we were really challenging the industry to transform, to reduce emissions levels actually across Europe. And there was a lot of pushback from the auto industry, and a wise old civil servant, actually who I was taking over from in that role, took me to one side and said, don't worry, because engineers are brilliant. And you know, human ingenuity and human creativity is the most tremendous power. And if you set a target and a goal, things that you never thought possible become possible. And you know, and it's great now to be involved in an environment where there's all of those brilliant engineering types, and we're going to see how far we can push it together.
Like no other time in history have we been at a moment where we can make such a clean and delightful break from poor choices of the past. I think we have to focus on that and say, I'm willing to make the shift, and if we don't address climate change, we know what our destiny is. This one Earth that we have is it. This is it.